Hello and welcome. I'm Mr. Olson, and this is your homework help video for the homework titled Linear Factors and Zeros of Polynomials. Let's get started by naming some polynomials by degree and number of terms. This first one, when I say by degree, I'm referring to the highest exponent. There's only one term here with only one exponent. That exponent is a 3, meaning that this is cubic. We could say that this is 3m cubed, so that's where this name comes from. It's a cubic. There's only one term, count them 1, so it's a cubic monomial. This one over here would be a quadratic binomial. Followed by just a number by itself. That's a constant. And again, only one term. Without a variable, it still counts as a term. So it's a constant monomial. In this last one, notice the highest exponent is actually here on the second term. So this would be a 6th degree binomial. We could say polynomial of 6th degree. I think just 6th degree is fine. Describe the end behavior of each function. All right, end behavior. For end behavior, all you need to look at is your biggest term. Everything else is inconsequential because as x becomes really large, these terms won't matter as much. So all we have to do is focus in on this, and all that really matters about it is the exponent, specifically whether it's odd or even. This one is odd. And the leading coefficient, and whether or not it's positive or negative. So this one is negative. So negative odd degree, doesn't matter what else is going on, it's all going to have the same end behavior. And what would that end behavior be? Well, we know with odd functions, the end behavior is not going to match. So it's either going to be down up or up down. But negative tells us that it finishes down, so we know this is definitely up down. For number 6, negative odd again, this is up down as well, and you can just write up down. That's totally fine. Positive even, that's going to be up up. It's going to finish up because it's positive, and because this 2 here is even, you know it's going to match. And we'll finish with a down up. Positive, leading coefficient, odd degree. Find all the zeros. Well, these have been given in factored form, which makes this pretty easy. I'll go ahead and do number 10 here. For number 10, when I say find all the zeros, this specifically means when y is equal to 0, also known as the x-intercepts. So I can set y equal to 0 here. So 0 equals x times 3x plus 5 times x plus 2. Now everything here is being multiplied. Here I see 3 factors with multiplication between each of them. So if any of these factors becomes equal to 0, because it is multiplying everything else, it'll make the whole thing equal to 0. So I can apply what's called the zero product property to say that if any of these is equal to 0, the whole thing is 0 and therefore true. So I'm just going to break them out and set them to 0 individually. X equals 0. Well, there's just one answer right there. 3x plus 5 equals 0. Well, this one just needs a little bit of manipulation. Subtract 5 from both sides. 3x equals negative 5. Divide both sides by 3. And we'll get that x equals negative 5 thirds. And x plus 2 equals 0. Subtract 2 from both sides. You get that x equals negative 2. All right. Write a polynomial function of least degree. What does this mean here? With integral coefficients that has the given zeros. Well, least degree with integral coefficients, that just means standard form. And the thing is, with like number 11 here, it's got these 4 zeros. We're going to say these are the only 4 zeros. Because technically, I could just keep adding in factors, and I could still keep these 4, and then, but I want, the smallest possible. So I want only these 4 and nothing else. So we'll just do number 11 here. Standard form, that's going to be a little tricky. I'm going to show you how to get it into that. Getting into factored form is really easy. You just basically have to flip the sign of all of these and when you turn them into factors. So if I want a 0 to happen at -1, I'll put in the factor x plus 1 into my equation. And now with that x plus 1 in there, if I plug in a -1, this will become equal to 0, and boom, y is equal to 0. And it doesn't matter what these are. If that becomes equal to 0, the whole thing is equal to 0. That's our zero product property. Next linear factor will be x plus 2. Next one will be x minus 5. Do you see how I'm getting these? I'm just flipping the sign of these, essentially. And to get one at 0, well, that's just x. All right, we have to do some serious distribution here to get this into standard form. So what I'm going to do is I'm going to FOIL these two, and then I'm just going to distribute the x to these two. And that's going to give me now just two factors, two expressions. X squared plus 2x plus x plus 2, and then x squared minus 5x. Combine like terms. Get y equals x squared plus 3x plus 2 times x squared minus 5x. And now when I do this distribution, I got to make sure I multiply first to first, first to second, second to first, second to second, third to first, third to second. That way I get every combination possible. So first to first, that's going to give me an x to the fourth. First to second, minus 5x to the third. Okay, so I'm done with this one. I multiplied it to both of these. I can move on to this 3x here. 3x times x squared. Well, that's 3x cubed. 3x times a negative 5x, well, that's negative 15x squared. All right, note that, move on to the next one. Third to first, third to second, and I'll get plus 2x squared. And our very last, minus 10x. All right, let's combine like terms. We'll just get y equals x to the fourth minus 2x cubed. Combine these up, we'll get a minus 13x squared minus 10x. So 1, negative 2, negative 13, negative 10. Let's see how we did. Yep, looks right. Number 14, we see this mult2 thing. What does that mean? Well, that means I want to have a 0 at positive 5, so I do x minus 5 to make that happen. I'm just going to put that same factor in there twice. And if this was mult3, I'd put it in again. I won't finish this one. That could take a while. But that's how you get this one started. Then you just do some foiling, some distribution, and you're done. All right, factoring. Well, I put in some simple factoring just to make your lives a little bit easier. Two numbers that multiply to be negative 5, but add up to negative 4. That's going to be a negative 5 and a positive 1. And this is factored. That's all it tells us to do. We're done. Let's look down at maybe like number 18, which has got a cubed term, but it's not that much more difficult because we can pull an x out of every single one of these terms and write it in front. So now I've got x times x squared minus 4x minus 5 after I divide an x out of everything. Now just do simple factoring on this. And man, that looks awfully similar to what we just did. You know, just copy down those two linear factors. And this is factored. Let's look at maybe a slightly more tricky one. Number 20, I can pull an x out of both of these, leaving behind an x squared minus 1. Well, this looks a little confusing because it doesn't have a b term, but our rule actually still works. Two numbers that multiply to be 0, not multiply to be negative 1, but add to be 0. Think about that for a second. Well, positive 1 and negative 1. Those will multiply to be negative 1 and add to be 0. And if you're not positive that this works, if you FOIL this, it will go right back to this. And number 20 is now factored. All right, last couple problems here. Approximate the graph of each function based off its end behavior. Maximum number of turns, zeros, if you can find them. Don't worry if you can't yet. and y-intercepts. All right, let's try, let's try 21. 21 is actually semi-tricky. Actually, 22 looks kind of tricky because of it doesn't have a greatest common factor. Well, 22. I'm not going to worry about 22. We're going to spend a whole day on how to factor ones like this. For 22, if you can find the zeros, great. Otherwise, just use end behavior, maximum number of turns, and y-intercepts, and you can do a pretty good sketch of this. 21, I think we should all be able to get this one pretty much all the way done. So first thing, let's factor out an x squared, leaving behind an x squared minus 1. And now I can split that x into like this first x squared into an x and an x, just to kind of remind myself that there's a double there, double zero there. And then this x squared minus 1, we just saw how to factor that. That's an x plus 1 and an x minus 1. All right, so that gives us a double zero at 0, because that's the value that make these linear factors equal to 0. So that's a 0 mult 2. We're also going to have a 0 at -1 and at +1. So let's add all of those in. This is a double 0 right here at 0. -1 and +1. This has got a positive leading coefficient and is even. So I'm looking for up, up, end behavior. And its y-intercept is 0, but we also see that because 0 was a 0. So y-intercept right there. Let's see if we can connect this all up. All right, so I need up, up, end behavior. So I'm going to come in from up, go through this one here. This is a double 0 here at 0. So it's just going to touch the x-axis, but then immediately turn around, bump back down, hit that 0 there, and it's off the page. Up, up, end behavior, correct y-intercept, correct zeros. That looks pretty good to me. All right, so that's good for this homework, and have a good rest of your day.